Hello, everyone. In our last class, we started with the actual chapter permutations and combinations. So, when we talked about the basic difference between the two, when to use permutation and when to use combination, we talked about what permutation is all possibilities of doing a thing where we are doing selection as well as arrangement, where position matters. And when it comes to combination, I'm only talking about selecting, choosing. I'm not concerned with who sits where, right? So in words, in digits, in numbers, in giving awards, in giving any secretarial or positions, we use permutation. In all selecting a committee, forming a team, all geometrical figures, we use combination. Okay. We talked about, then we started with permutation. The first thing that we talked about was formula. NPR, factorial n upon factorial n minus r, where r can only be 0 to n. Basically, all whole numbers till n. All whole numbers till n. Because if I've said 20 books in total, I can have a minimum of 0 book selection and I can have a maximum of 20 on 20 selection. I can't have anything other than that, right? So R will be 0, 1, 2, 3, and so on. Yes. Then we talked about different formulas and all. We also talked about NPN. What's NPN? N factorial by n minus n 0 factorial. That makes it n factorial. So, what is NPN? If I say 5p5, we deduce that it is 5 factorial. 4p4, 4 factorial. 6p6, 6 factorial. So, when I'm saying 4p4, what do I mean? When I say the word p, I mean that you select and then whatever is selected, you're going to arrange. Right? That is what we mean. So if I'm saying 4p4, it means out of 4, you need to select 4 and then arrange those 4 letters. So if I'm selecting all of them, I'm not even doing the portion of selection, right? What am I doing? I'm not selecting anything. You have 4 people. I'm selecting all the 4. So there's no selection involved, right? The only job involved here is what? Positioning, arrangement, right? So 4p4 means arranging 4 people. 5p5 means arranging 5 people. 6p6 means arranging 6 people. From 6, if you are taking all the 6, that is no selection, right? When will I be selecting? If I write 6p4, that means out of a total of 6, I am first selecting 4 people, and those selected 4 people will then be arranged, right? That is what 6p4 means. But if I'm saying 6p6, there's no selection involved. The only thing that is involved is the 6 people that I presented you, the 6 letters that I have given you, just arrange them. So how can 6 people be arranged? 6 factorial. How can 5 people be arranged? 5 factorial. How can n people be arranged? N factorial. So if I only have to arrange, there is no selection. See, when I'm doing combination, I'll be doing only selection. When I'm doing this, I'm doing the permutation. So I'm selecting as well as arranging. But if I'm saying NPN, that means out of n, you're taking everyone. If I'm taking everyone, then there is no selection involved. The only thing that is involved is the given letter, the given options, the given objects should be arranged, should be put together. So 1, 2, 3, 4, or 4, 3, 2, 1, 5, 7, 6, 4. How will I arrange? That's the only question. So if I have 5 people and I want to only arrange them, it's 5 factorial. If I have 4 people, I only want to arrange them, 4 factorial. If I have 3 letter, I only want to arrange them, 3 factorial. If I have 5 people and I want to select 3 and then arrange, what will I write? 5 people. So out of 5, select 3 and then the selected 3 will be arranged. That is 5p3. Understood? Yes. So if I don't need to select, I only need to arrange. We directly do factorial. So factorial n, this will be number of ways of arranging n objects. Only arranging. There's no selection involved. Right? No selection. Only pure arrangement. No selection. Clear? Agree? So now imagine, see, earlier in the first class itself, we talked about common sense, the fundamental principles of addition, of multiplication. So in that question, when I said don't write, suppose I gave you the letters R, O, S, E, you need to form a word. If I did not say form a word of how many letters, that means all the four letters. So I need to form a four-letter word. So the first position can be filled in four ways. Second place can be filled in three ways. Next two, next one. So we used to write 4 into 3 into 2 into 1. Yes. Now I'm saying I have four letters, form a word. If I'm forming a word, it's a question of permutation. Do I need to make a selection? No. I need to use all the four letters. So my only job is what? Arrange. ROSCSORESEOR. What should I do? The only part is arrangement. So in how many ways can four letters be arranged? 4 factorial, aren't they same? So when we were doing the first place can be filled in this way, the second can be filled in this way, the third can be filled in this way, that was permutation. That fundamental principle concept question, some of them, this one, these all were permutation. Any with replacement question, it is neither permutation nor combination, it is basic fundamental principle. The darkness one, right? That's basic principle. Clear? Clear? So when we only need to arrange, we directly use factorial. Now in the same question, if I would have said, you form a word, but repetition is allowed. So it's neither permutation nor combination. I'm using basic common sense. The first place can be filled in four ways. The second place can be filled in four ways. The third place can be filled in four ways. So four powerful. Yes? Clear? So if I give you five letters, form a word. Five factorial. If I give you seven letters, form a word. Seven factorial. So if I only need to arrange, we are directly going to do factorial. But if out of seven letters, I want a five-letter word. So online, I'm still waiting for an answer. I have seven letters and I want to form a five-letter word. What will I do? I have seven letters and I want to form a five-letter word. So out of seven letters, my job is first to select five and then the selected five needs to be arranged. So we can do 7P5. If all the seven letters had to be used, then 7 factorial directly. No selection, only arrangement, direct factorial. Yes. Suppose I have all the five vowels with me. Form a word. Form a word. Form a word means form a five-letter word. So five letters are already there. So no selection involved. The only thing involved is arrangement. So how can these five letters be arranged? 5 factorial. In how many of them the word will start with A? The word starts with A. So if the word is starting with A, the first letter will be filled in one way, right? So the remaining four places and there are remaining four letters. No selection, no restriction, nothing. Four letters needs to be arranged. That's 4 factorial. Yes? Yes? Starts with A, ends with O. Starts with A, ends with O. Starts with A, ends with O. If it
3
starts with A,
factorial.
there is only one place to fill this. If it ends with O, there is only one way to fill this. Three letters and three positions left. Is there a selection involved? No. There's only arrangement involved. So 3 factorial. Yes? Question. Suppose the word is triangle. Very important. Huh? Form a word. Form a word. Answer. Form a word. 8 factorial. 8 factorial. 8 letters, only arrangement necessary. Starts with a vowel. End with a consonant. Start with a vowel. End with a consonant. So the given letters, there are how many letters? 8 letters, out of which there are three vowels, I, A, E. There is five consonants. So now what I want is my first place should be filled by a vowel. So the first place can be filled in how many ways? Three ways. The last place has to be filled by a consonant. So the last place can be filled in the
Seven
last
ways.
place can be
Oh,
filled
sorry.
in five ways.
5 ways.
Now, first place is filled, one person sits there, one person sits at the end, two are gone. Remaining six people. So those six people only needs to be arranged. So those six people can be arranged in how many ways? Six factorial. Yes. Vowels sit at even places. Vowels sit at even places. So how many vowels? Three. How many even places? Second, fourth, sixth, eight. There are total eight, na? So eight locations. So how many even places are there? Second, fourth, sixth, eight. Four. So out of those four places, I need to make my three vowels set. So what is my job now? Wrong. Wrong. But there are four places. How will I make them set? First, we need to select three places where the vowels will sit. And then in those selected places, I need to arrange. So in this case, my job is both selection and arrangement. So out of four places, I need to select three and then arrange in those three position my vowels. How many ways are there? Wrong. Wrong. Yes. It will be 4P3. Vowels sit at even places. So there are four even places. Second, fourth, sixth, and eighth. In those four places, I need to first select which three places will my vowel sit. Once I've selected those, I will then find out how can I arrange my selected places. So out of four, I need to select and arrange three. So 4P3. Is it understood, guys?
Yes, ma'am.
So the three vowels have set. Now the remaining is five consonants. So five consonants can now sit. So eight total position, three have been used. Those are the restriction. Now, is there any restriction on consonant? No, they can sit as they like. So how many places are left? Three filled, five left. How many people left? Five consonant left. So do I need to make a selection now? No, I only need to make an arrangement of five consonants. So five consonants can be arranged in
5 factorial.
five. That's my total answer. So vowels can be seated in the even places in 4P three ways. The consonants can be seated in factorial five ways. Total number of ways this. You need to calculate everyone. Huh? Just explaining right now. Clear?
Yes, ma'am. Yes, ma'am.
Number 4. Vowels are together. Very important. Let's understand. There are two ways I'll explain. I usually like the second one. Okay. Vowels are together. That means I want A, E, and I to be together. Wherever they sit, they should sit together. Right? So I have a total of 8 positions. The vowels can sit in these three places one way. The vowels can sit in these three places two ways. Vowels can sit in these three places three ways. 4, 5, 6. So vowels can sit in 6 ways. Yes or no? Yes, in either first, second, third, or second, third, fourth, or third, fourth, fifth, and so on. So there are 6 possibilities to make them sit together. Yes? No, it's still left. So if suppose the vowels are sitting in the first three place, now they will fight for who will sit in the first, who will sit in the middle, who will sit at the third. Yes or no? So they have to be together. But we never discussed who will sit where. Among those three, how will they arrange? A, E, I, E, A, I, O, E, how? Right? So how can three vowels arrange among themselves? 3 factorial. Now this is complete for vowels. So vowels can sit in 6 possible situations. In each of these situations, there are factorial 3 ways to arrange among themselves. So till now, what we have done is only make the 3 vowels sit. There are still 5 consonants left. and there will be 5 seats left. So five consonants can be arranged in 5 factorial ways. Yes? Okay. Or see, every single time it's not possible to do this. So what's the other way around? There are 8 letters, 3 vowels, and 5 consonants. What do we want? Vowels together. So rather than treating the vowels as different individuals, let us think of them as a couple, as a bundle, right? Whoever we want together, we will treat them as a bundle. So the 3 vowel bundle and the consonants. How many? 5. So 5 individual consonant treatment and 1 bundle treatment. Total 6 people. How can 6 people be arranged? 6 factorial. So when I'm saying the bundle, if the bundle is sitting in the first position and then the 5 consonant come. So as soon as the bundle drops down at the first position, it will automatically take 3 6 for second, third. And then the 5 consonant comes. If the bundle drops down at the third place, so 3, 4, 5 is vowel. Before and after will be consonant. Clear? So the 5 consonants and the vowel bundle makes it 6. So 6 factorial. Now the bundle has 3 vowels. Now those 3 vowel can change among themselves the seats. So those three vowel can change within the bundle in how many ways? Wrong. 3 factorial ways. Yes. It's always easier to form a bundle. Whoever you want together, form a bundle and then see whether in the bundle they have the luxury to interchange or not. For example, if I would have said, in how many words, same question continuing, in how many words angle appear? So the word was triangle. What I want my word to have angle. That means what will I do? I'll treat them as a bundle. I'll treat it as a bundle. Wherever it will sit together. Angle then T-I-R-T-R-I. Angle then T-I-R. I bundle T-R. Wherever they sit, they'll sit together. So rather than treating as 5 different letters, let's treat them as a bundle. Yes? So how many letters? T-R-I bundle. 4 people. 4 people can be arranged in 4 factorial. Now, the bundle has how many people? 5. Are they allowed to interchange? No, because as I said, I want angle. I want A to be in first, I want N there, then G, then L, then E. So they're not allowed to interchange among themselves. They need to sit in that specific position. Understood? Online
Yes, ma'am.
understood.
Ma'am.
Now,
Yes,
same, the
ma'am.
word was triangle. There are 3 vowels and 5 consonants. Right? I want all the consonants together. I want all consonants together. I want all consonants together. What should I do? Bundle of the 5 consonant. How many people? 3 vowels and 1 bundle. 4 people. How can 4 people sit? 4 factorial. Then in the bundle, the 5 consonants are together, but they can arrange among themselves. So those 5 consonants can be arranged in 5 factorial.
5 factorial.
Yes. If I say all consonants are not together, all consonants are not together. So what I'm trying to say is all the 5 should not be together. I don't have a problem with 4 of them. I don't have a problem with 3 of them together. I don't have a problem with 2 of them together. I don't have a problem with everyone being different. So how can I think of so many cases? 4 together, 3 together, 2 together, all different. Rather than that, like the darkness. From the total, we will remove the cases which I don't want. So from total, what can I do? From total, we will remove the case when all of them were together. So total minus all consonants together. Total minus all consonants together. Total factorial 8. And when all of them are together, I don't want that case. So I'll remove that case. How many cases are there? Factorial 4 into factorial 5. I'll remove that case. Understood? Guys, understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
The word is number. Form a word. Right. Starts with U. Starts with a vowel. Ends with consonant. Keep on doing it. Does not start with N. Does not start with N. All the vowels are together. All consonants are not together. A U E appears. Right. So the first word, number. So there are a total of 6 letters, out of which 2 vowel and 4 consonant. Agreed? So first, form a word. Total 6 letters, so 6 factorial. So number 2 starts with a vowel, ends with consonant. First place can be filled in 2 ways. The last place can be filled in 4 ways. Remaining 4 letters in between, 4 factorial. Does not start with N. That means the first place is not allowed to be filled by N. It can be filled by anyone else. So the first place can be filled in 5 ways. Remaining 5 places, 5 factorial. Number 4, all the vowels are together. So we form the bundle of the vowel, 4 consonant and this bundle, 5 people. Those 5 people can be arranged in 5 factorial ways. Yes. And then the bundle has 2 vowels. They can arrange among themselves in factorial 2 ways. Yes.
Yes, ma'am.
Fine.
Yes, ma'am.
All the consonants are not together. Whenever the question is all are not together, it is always going to be total minus together. So total factorial 6 minus together. What do I want together? I want the consonants to be together. So those consonants will be formed as a bundle. So 2 vowel and this bundle will be 3. So 3 ka 3 factorial. Within the bundle, there are 4 consonants. Those 4 consonants can be arranged in 4 factorial ways.
Yes, ma'am.
Yes. Next is
Yes, ma'am.
UE appears. So UE will be formed as a bundle. After that, there are 4 more letters N, M, B, R. Yes. So those are a bundle. And these 4. So total 5 letters. 5 letters can be written in 5 factorial ways. Then UE appears. So can I interchange UE, the bundle? No, because as I said, I want UE. I don't want E. So that arrangement is not allowed. Clear?
Yes, ma'am.
Yes, ma'am.
Done?
Yes.
7. Question. 0, 1, 2, 3, 4. Form a 5-digit number. Second, form an even number. Form a odd number. Try. Number 1, form a 5-digit number. Answer. So the first place
Four.
cannot be filled by 0. because then it will be a 4-digit number. It will no longer be a 5-digit number. So the first place can be filled in 4 ways. One is gone. So remaining 4 digits, that will be 4 factorial, right? Form an even number. When I say an even number, basically I'm only concerned with the last place, right? So the last place can be filled by 0 to 4, okay? And the first place,
3 ways.
this can't be done together because 0 has a problem with both the first and the last place. If 0 is sitting here, yes, my number is even. In that case, my first place, the remaining 3 can be filled directly by 3 factorial ways. But if the last place is filled by either 2 or 4, there are 2 ways to fill this position. The first place can be filled neither by, not even by 0, so 2 people gone. So the remaining 3. 4 factorial. So the first place can still be filled in 3 ways because that number either 2 or 4 goes and even 0 goes. So out of 5, 2 people are not allowed. So remaining only 3. Hana. And the remaining 3 places can be filled in any way. 18 ways. Yes, total 42. Is it clear, guys?
Yes, ma'am. Yes, ma'am.
Yes.
Clear? Form an odd number. In this case, it's easier. So if I want an odd number, the last place has to be filled by 1 or 3, 2 ways. Remaining 4 people. But in those 4, there is a 0. 0 cannot sit in the first place. So there are 3 ways to fill this position. Now remaining 3 letters can sit in any which way. 3 factorial. So 6 into factorial 3, 36. Yes?
Yes, ma'am. Yes, ma'am.
Any doubts?
No, ma'am. Oh.
There are 3 couples. You need to make them sit, but the couples will always sit together. How can you make 3 couples sit when husband and wife are always going to sit together?
3 factorial.
Wrong. Still wrong.
3 into 3 factorial into 3 factorial.
Wrong.
3 into 3 factorial.
Wrong. So 3 couples, one husband, one wife, a bundle, one couple. Another husband, another wife, another couple, another bundle. One husband, one wife, another couple, another bundle. So 3 bundle, 3 couples. They can be arranged in factorial 3 ways. Yes. Now every bundle, say they need to sit together, but they can sit left, right, now. Husband can be on the left or wife can be on the left. So the first couple, first husband, wife can arrange among themselves in how many ways? 2 factorial. The second couple can also do that. The second couple can arrange among themselves in factorial 2 ways. The third couple can arrange among themselves in factorial 2 ways. Yes or no?
Yes, ma'am.
Understood.
Yes, ma'am.
Everybody clear? Question. There are 3 girls and 3 boys. Number 1. How can they sit? Step second. No, all boys are not together. Third, no two girls sit together. 4. Boys and girls alternate. Right. Number 1. 3 boys and 3 girls. How can 6 people sit? 6 factorial. Number 2. All boys are not together. All are not together is total minus together. Total is 6 factorial. If the boys form a bundle, there are 3 and 1. 4 people. 4 factorial and the bundle will be 3 factorial. Yes? Okay. What about the third one? No two girls. First, my question is 3 and 4 same? Because the third one says that the girls should not be together. It did not say that the boys are not allowed to be together, right? So it can be a scenario like boys, girl, boy, boy, girl, boy, girl, boy, and girl. So none of the girls are together, but the boys are together. So third and fourth is not same, right? So how do we do in such a sum? I don't want the girls to be together, right? So let's make the boys set first. How many boys are there? 3 boys are there. So 3 boys can sit in how many ways? 3 factorial. So boys. Now the girls will sit in the gap, right? How many gaps are there? There are 4 gaps. In these 4 gaps, the girls can select any 3. And once you have selected the 3 position, they can also arrange. So here the job is both selection and arrangement. Out of 4, I want to select 3 position, and then in those 3 position, I want them to sit. How many ways are there? 4p3. Understood? Understood? Boys and girls alternate. Again, let the first 3 boys sit. 3 boys can sit in factorial 3 ways. Now, neither the boys nor the girls can be together, right? So the girls can sit in these 3 places. 3 places, 3 girls. No selection necessary, only arrangement. Or the boys sit again factorial 3. The girls can sit in these 3 positions. Yes. So again 3 position, 3 girls factorial 3. So 2 times factorial 3 factorial 3. Understood? Guys,
Yes.
understood?
Yes, ma'am.
Any doubts?
No, ma'am.
No, ma'am.
That's it for today's session.